Alright, I made this little, you know, for shits and giggles. I've never actually built one of these before, but, little 555 base charge pump. I built a positive version, that doubles the voltage. And, this is from, Elliott Sound Products website. But anyway, this is kind of a common sort of circuit. And this is right here, this is a negative charge pump, so you can make it go either way. And like I said, you're welcome to read that. You can see, some projects 95, sound-au.com, etc. So, you can go check it out if you want to learn more about. But yeah, I mean, this thing. Let's see. In fact, that's the output right now. I got 12 volts fed into it, and so you can see. Let's see, there is, C1 is charged up to 26 volts, 26.7 currently. And that's with 12 volts supplied to it, and that's the waveform coming out of it, off of, across that last capacitor you see there, that C5, I guess it is. Or no, actually, that's across this capacitor right here. That's going to the analog discovery. So that's the overall output, but I'm just looking at the waveform across that. That's where that's coming from. So yeah, it's pretty neat. I mean, but what you got to understand, is that this is one way, to generate or to make a charge pump. The actual charge pump part, is pretty much, pretty much just these diodes here. So anytime you have like a, like a digital square wave, that's, it's got enough, basically current capacity to charge a capacitor, and you can make a, a charge pump, and they're, used quite often. Let's see here. Yeah, like let's see, not here, but like a chip like, like this. The Max 232, RS232 line driver. Yeah, if you have any of these lying around, I mean, they have a built-in charge pump with a frequency source and everything, and you hook a bunch of capacitors up to it, and then it has basically voltage outputs, that you can actually use for external things, plus or minus 8 volts. So, and I actually happen to have a bunch of these. I mean, I got like 20 of them that I didn't even know I had years ago, but when I was buying such things, I could have used them. But they got 1 microfarad capacitors hooked to the pinouts, and then you got certain outputs, and but you got certain outputs, and that you can, that are available. Apparently these, actually put out the voltage for pins, from pins 2 and 6, where you can use it for whatever. So, so that's a great example that, basically anytime you could almost certainly, make a charge pump with an Arduino, the outputs, it's got enough current to, charge a, certainly 1 microfarad capacitor, unlike the, 100 microfarad capacitors I got in this thing. So, but they can come in handy. And if you, had an AC square wave, like that one I built with the Wheatbridge oscillator the other day I made a video about, well, in theory, you could actually power a cascade multiplier with that, and generate like 100 volts without a transformer if you wanted to, maybe. Because that put out a pretty big, plus or minus 16 volt waveform. You could do something with that. But at any rate, charge pumps are simple, and they come in handy if you're doing, H bridges and so forth, and you want a high side drive your NPN transistors, or your FETs, as the case may be, and you need a higher than VCC power rail, you can use some of your digital logic, to actually put a charge pump in there so you can power your high side FETs, so that they can both be, in channel, if you like. So, as an example. So, anyway, but yeah, I thought you'd find it interesting. It's a nice little circuit. Mine is actually running at like 7 kilohertz because I didn't use the exact value of components he did. Because his is supposed to run at 30 kilohertz. So I thought I'd, slow it down, take a look at it, because you don't have to really run it at a high frequency if you don't want to. So, but yeah, I mean, like I said, it's a pretty neat little circuit. But like I said, there's lots of ways of generating it, and this is the business end, though, that any square wave source you can put into this will create, in fact, a cascade multiplier. Just make sure your capacitors are rated the right voltage. I just used some small signal diodes on this. Not whatever he had. So and again, that's one of the reasons I ran it at a lower frequency, in case I wanted to use 4004s or something, which that probably would have worked fine at 30 kilohertz too, honestly, but not dealing with a lot of current, but who knows. But anyway, I just wanted to cover that a little bit. So cheers.